This section is about the transfer characteristic of an op-amp. Let's start with the inverting amplifier with a negative input voltage. This is a differential representation of the op-amp, because the input signal is applied between the two input terminals of the op-amp. As will be shown later, the usual arrangement is the single input circuit where one of the input terminals is grounded. A transfer characteristic relates the input and output of the op-amp in a graphical way. Usually, the input is shown on the x-axis of a graph, and the output on the y-axis of the graph. The input is the independent variable and the output is the dependent variable. The relationship between the input and output for an inverting amplifier, with a negative input voltage, is shown in the second quadrant of the graph. The input voltage is negative, and the op-amp produces a positive output. At some input level, which is quite low, typically in the range of micro or millivolts, the op-amp output saturates. This is when the op-amp output reaches the supply voltage level and stays there. From this second quadrant curve it is already clear that the gradient of the curve is quite steep, which is due to the high gain of the op-amp. A small input voltage produces a much larger output. The inverting amplifier, with a positive input voltage, completes the analysis of the transfer characteristic. This portion transfer characteristic sits in the fourth quadrant. The input voltage is positive and the output is negative. A small variation input voltage results in a large output voltage swing, until the output saturates at the negative rail. The gradient is the same in both quadrants. A small positive input voltage results in a much larger output voltage. The gradient of the curve is the gain. In this case, the gradient is negative. This is because the gradient is given by the change in the output voltage, divided by the change in the input voltage. And the change in the output voltage is negative, because it runs from a positive supply voltage, down to a negative supply voltage. This slide is about a short summary of the inverting amplifier with negative and positive input voltages. We start with the inverting amplifier from the previous slide, where the input voltage is negative and the output voltage is positive. This is the differential input representation of the op-amp. It is a differential input single-ended output, because the output is taken from a single output terminal in the ground. We compare this with our previous representation of the op-amp. This is the single-ended input that we referred to earlier. The signal is applied to negative terminal and the positive terminal is grounded, and therefore, it is common to the input and output circuits. The input voltage is negative while the output voltage is positive. We also have the inverting amplifier, but this time it is with a positive input voltage and a negative output voltage. And we compare this with the single-ended circuit we used earlier. The input is positive and the output is negative. Because it is an inverting amplifier, the gain is negative. In the previous slides, we completed the analysis of the transfer characteristic for the inverting amplifier. In this slide, we are going to illustrate the transfer characteristic for the non-inverting amplifier. And this is the non-inverting amplifier. Note that the input terminals of the op-amp have been swapped from what they were with the inverting amplifier. Now, the positive is at the top and the negative at the bottom. With the inverting amplifier, the negative is at the top and the positive at the bottom. We start with a negative voltage input voltage to the op-amp. And because it is a non-inverting amplifier, the output is also negative. We use the same x and y axis as before, with the input voltage on the x-axis, and the output voltage on the y-axis. The transfer characteristic falls in the third quadrant. As the input voltage increases, the output increases much faster, as shown by the steep gradient of the red curve. If the input voltage continues increase, a point is reached where the output voltage saturates at the negative supply rail. The input voltage varies over a very small range, typically in the micro or millivolt range, before the output of the op-amp saturates. Next, we analyze the non-inverting amplifier with a positive input voltage. The transfer characteristics falls in the first quadrant, which is for a positive input and positive output voltage. The characteristic is the same as before. The input voltage varies over a small range, while the output voltage varies over a range from 0 to the supply voltage. When the output voltage reaches the positive supply rail voltage, the op-amp is in saturation. There is usually a delay before an op-amp can recover from saturation. Therefore, this situation should be avoided because it will distort the output waveform. The input voltage varies over a small range, in the range of micro to millivolts. In this instance, the gain is positive. In this slide, we are summarizing the non-inverting amplifier, as we did before with the inverting amplifier after we presented its transfer characteristic. We start with the non-inverting amplifier, with a positive input voltage. And compare that with the single-ended circuit we used previously. When the input voltage is positive, the output voltage is positive. It is called a single-ended circuit because the negative terminal is grounded and the signal is applied the positive terminal. The signal is applied to a single terminal, therefore it is a single-ended circuit. This is the non-inverting amplifier with a negative input voltage. This is compared with the single-ended circuit we developed earlier. The negative terminal is grounded, and the negative signal is applied to the positive terminal of the op-amp. As before, the output voltage is the input voltage multiplied by the gain. The gain is positive for the non-inverting amplifier. This is the end of section 6 of this course. In the next section, we have a short review of the material in the previous section.